everybody, welcome to this MPLS Bootcamp series. So we are done with section 1, so let's start with section number 2 under domain 1, which is layer 3 intra-AS MPLS VPNs, and we are doing based on iOS operating systems. Alright, so let's start with section number 2, which is configuring intra-AS MPLS VPNs. So this section will make you understand regarding what is MPLS VPNs are all about and how to configure them using various routing protocols, and we'll also talk about the traffic flow through MPLS VPNs and the different features of MPLS VPNs by which you can attach the customer routers, and the customer routes can be propagated using a service provider core, and you'll be learning how MPLS is involved in doing that particular routing process. So let's start with MPLS VPN overview. That's the main agenda. So in this section we'll talk about what is MPLS VPN and what does MPLS brings into the table in terms of MPLS virtual private network and how to accomplish that. So to do that, I have to use another lab, which is kind of topology number 2. So it's been made here. This is the topology that I'm going to leverage for section 2, and you can see that I have got the MPLS SP core network, which is laid up. So I've got R1, 2, 3, and 4, which is part of the SP core network. It will be part of AS100, and it will run EIGRP AS of 100. Okay, and what I have over here is different customers. So I've got multiple customers. Like I've got 2 customers over here. You can see that I've labeled that with a purple color and with a blue color. So you can think like this is purple customer, or you can say customer A and having 2 different sites, like site 1 and site 2. So think like site 1 is part of the eastern region of the world, and site 2 is part of the western region of the world. All right. Likewise, I've got another customer, which is customer B, and it has also got similarly different sites located in different parts of the world. Okay, so that's the first thing. So what does MPLS VPN brings in the table? So first of all is we can leverage using MPLS virtual private network. Let me take up my pen over here. So using MPLS VPN, so what you can do is you can attach multiple sites for same company. Multiple sites for same company can be connected, right? And we can do the routing for those sites, right? That means it will lay the foundation of providing a private WAN service for those customers. So my service provider that we have over here, we can call this an SP core. This SP core is going to offer a private wide area network or a private WAN service for those customers, and we normally call that technology, when we run MPLS in that SP core, providing the private WAN service to attach those customer and to exchange those customer private routes from one AS to another AS, or you can say through the MPLS SP core, the private routes of the customer can be exchanged between the sites. We can call that as a function of MPLS VPN. So we're trying to leverage an MPLS based virtual private network by which we can connect the multiple customer sites together, and we can exchange the private routes of those customers from one site to another site, making sure that we isolate those particular traffic. Okay, so what do I mean is, for example, you can think like that this is customer A site 1, right? This is customer A site 2. Likewise, I've got another customer called as customer B site 1 and customer B site 2. And notice one thing over here, the customer A site 1 is having some sort of private routes, right? So this networks are private routes. This is your private routes. Okay, now this particular private routes, this customer A site 1, this is the edge router. So behind this particular edge router of that customer, it can have, other core routers. It might have a, big gigantic, routing domain. We're not bothered about that. Behind this, it can have a gigantic routing domain. That's fine. But what is the major intention is I would focus that the router which connects, from the customer side to the SP core edge router, that is the router I'm interested to talk and to do routing with. So this particular edge router of the customer that connects to the SP core edge router, it is called as a customer edge router, right? We call that as the term called as customer edge, right? Customer edge, also called as a CE router, right? Customer edge router, CE router. Likewise, this router, which is in the SP core, is called as the provider edge router, which is also called as the PE router, okay, short form. So the PE router normally is the edge router from the SP core side that connects to and to the routing with the customer edge router. So we need to have a PE to CE based, routing communication. Okay, likewise, this is the PE router, okay, which talks to the customer A side 2. So this becomes your customer edge router. And likewise, we'll have a PE to CE, routing communication between these two router, right? So likewise, so I've got, customer A site 1 is using, private routes. You can think like, this 10.1.1.0/24 and 10.5.5.0/24 are the private routes, right? Likewise, you can see that the customer A site 2 is using, the private routes of 10.2.20/24 and 10.8.8.0/24. Okay, so as long as, within the same company, between the different sites, as long as I have a unique private routes, that's fine for me, right? But there can be a situation, or there will be a situation where I have to attach, a second customer, say customer B. Now customer B also have the same network like 10.1.1.0/24 like customer A site 1, right? So it can have an overlap, but this is absolutely fine because these customers are using the private routes which falls under RFC 1918 private address scope, so they are free to use those private IP range, and between the different customers, this is absolutely allowed. So within the, unless and until we have got the isolation within that or the uniqueness within that same company, this is fine, right? But different companies can use the same network internally, right? Now you can see that to my job, and similarly you can see that R7 is using 10.2.20/24 network, okay, and it is also used by customer B of, or customer A of site 2. So customer B of site 2 and customer A of site 2 has got this network. Now it is the major important thing that to understand over here is once those private routes, okay, are exchanged, right? So once those private routes are exchanged to from the customer edge to the provider edge, it is the responsibility of the provider edge to keep that particular route in a separate container, right? So that this particular container does not interchange the routes by default with the routes that it is receiving from the other customer, right? That means I need to have two separate isolation based routing tables over here, which is normally called as VRF, right? Virtual routing and forwarding instances. So I need to create the VRF instances on that provider edge router, which will help me to isolate and keep those customer routes in a segregated manner. So I need to go ahead and create something called as a VRF route over here. So just for a sake, I'm going to create some sort of VRF route over here. So one VRF for the purple customer, right? This is for customer A VRF, and I need to create another VRF for my customer B, right? So I need to create that two virtual routing and forwarding instance into my this provider edge router. Okay, so I will explain you the meaning of the global routing table and the VRF shortly. Hold on for that. But just as a very short overview is whenever the routes are exchanged from this particular customer site customer site 1 and it goes to the provider edge router, the provider edge router must keep that route of customer A site 1 or the customer A route in a separate VRF. Likewise, customer B route, when it is getting exchanged to the provider edge router, make sure that the customer B routes are kept separated in a separate VRF instance, right? And by default, the VRF does not communicate between each other, right? So the routes that is part of the customer A VRF instance, does not interchange the routes with customer B VRF instance, and vice versa, right? So the customer edge, as I've told you, that it will go ahead and communicate its private routes to the provider edge, right? So the customer edge would go and run propagate those routes to this provider edge, and the provider edge will receive those routes and keep this inside a VRF instance, right? In a VRF instance. And that means we need something called as a CE to PE routing protocols. So I need to deploy some sort of PE to CE routing, by using which I can form this PE to CE based neighborships, and I can go ahead and receive those customer routes. Likewise, think about this customer A site number 2 will also exchange its routes to this provider edge, right? So this is my customer edge again, this is my provider edge, and this should keep those routes in this VRF instance. Okay, and I should have something called as the provider edge to provider edge should actually propagate those routes. So the routes that is part of this particular VRF instance for customer A, and the routes that is available in the VRF instance for customer A site 2 should be propagated to each other. That means there has to be some sort of PE to PE routing between these two routers, by which these routes could be exchanged from one PE to another PE and can be delivered to those can be interchanged to those respective customers. That means now the customer A site number 2 will have the routes of customer A site 1. That means this 10.1.1.0/24 and the 10.5.5.0/24 route should be learned via this customer A site 2. Likewise, the customer A site 1 should know about the customer A site 2 routes, which is 10.2.20/24 and 10.8.8.0/24. That means I have to use PE to CE routing, and we'll leverage that. We're running some sort of routing protocols. I need to use PE to PE routing protocol as well, and we'll see how to do that. Now similarly, when this traffic goes from the customer B site 1, it should be kept in a separate VRF. So this should be a separate VRF for customer B, right? Whatever private routes it is exchanging, make sure that it is kept separate. Likewise, those routes should be kept in a separate VRF for customer B, and I need to have a PE to PE based VPN or PE to PE based routing over here, which will ensure that those particular routes can be exchanged from the customer B VRF of router 1 to the customer B VRF of router 4, and vice versa. And while doing that, I ensure that these two PE to PE communication are always kept isolated and kept unique and kept separated. There's a reason it is called as a virtual private network. That means you have got one VPN, which is from this customer to this customer through that SP environment. It is basically one virtual private network which you are trying to lay, and you have got another VPN which is over this particular MPLS network from customer B site 1 to site 2. There's a reason it is called as MPLS based virtual private network, or we call that as MPLS layer 3 VPN. The layer 3 because we are leveraging using the layer 3 IP addresses. We are routing layer 3 information, and we are forming the VPNs using IPv4 routes. That means we using your layer 3 addresses, right? So that's the basics of forming it. So my first job is to go and create define those VRFs on that provider edge router, right? So far you understand that I need to keep those routes into separate VRF. I need to configure those VRFs on my provider edge router. And for my PE to C routing, what I can do is I can leverage multiple protocol, right? So for leveraging this PE to CE routing, I can use any protocol, and we will use multiple protocols between those PE to CE routers so that I can go ahead and differentiate the behavior of them. So I can use the PE to CE routing. The PE to CE routing protocols can be of many types, like I can use RIP, I can use EIGRP, I can use OSPF, I can use BGP. Further, I can use static routing, or I can use default routing, right? So I've got many choice, right? I've got many choice by which I can run this PE to C as a different routing protocols and go ahead and formulate that. So first thing first, before I discuss more, first thing first, so let's go ahead and run that PE to C routing, and let's go ahead and configure this SP core with the IP addresses. Let's go and configure the customer sites with their respective IP addresses, right? And then we'll go and turn on the attention for MPLS VPN and the internal part of MPLS VPN, how to configure that. Okay, so let's go for the basic configuration now. So I have to go to R1 and I have to go ahead and configure my so I've got one loopback, and I have got here 3 physical interface. So let's go ahead and configure those. So this interface loopback 0, the loopback is in /8, so it's 1111 in /8. The physical interface first is E0/0, no shut. The IP address is 192.1.15.1. Interface E0/1, no shut. This should be 12.1. And E0/2, no shut. This should be 16.1 as per the topology. That's it. So that's all. And what I'll do in R1 is I will go ahead and enable MPLS on this router globally and enable MPLS on the interface which is reaching towards the SP core router, right? So I'll say MPLS LDP router ID to loopback 0. Okay, and I'll say MPLS, I'll go to the interface which is E0/1, and I will run MPLS IP over here. Enable MPLS on the E0/1 towards the provider router, right? What is provider router? Done. So this is over, and then let me go and configure EIGRP on AS100. So router EIGRP AS100, no auto summary. Advertise the SP core network, which is basically the loopback and basically the link towards the R2, which is 192.1.12.0. That's it. So this is my EIGRP is running on the SP core interfaces. That's all. So I save the config. Likewise on R2, it has got one loopback and 2 physical interface. So loopback is in /8. And the physical interface is E0/0, no shut. This is going to be 192.1.12.2. And the next one is E0/1, no shut. This should be 23.2. The router EIGRP AS100, no auto summary. Network is 2. And network is 192.1.12. Network is 192.1.23. And as expected, I have an EIGRP neighborship with R1. Those things are fine. Let me go ahead and enable MPLS. MPLS LDP router ID to loopback 0, and I go to both the interface E0/0, MPLS IP, E0/1, MPLS IP, and MPLS LDP neighborship is also formed towards R1. All good. I save the config over here. Let's go to 3. R3 has one loopback, so interface loopback 0. This is n/8. Interface E0/0. No shut. This IP is 192.1.23.3. E0/1. No shut. This IP should be 34.3. And let's configure MPLS LDP router ID to loopback 0. Interface E0/0. MPLS IP E0/1. MPLS IP. And I will go and establish EIGRP. So router EIGRP AS100. No auto summary. Network for 3.series. And network for 192.1.23.0. and network for 192.1.34.0. All right, saved. Let's go to 4. Okay, LDP is from 2 R2. Yeah, let's go to 4. So at 4 I would need 1 loopback and 3 physical interface. So interface loopback 0. This should be n/8. E0/0. No shut. This IP is 192.1.34.4, and if I go to E0/1, this should be no shut. This should be 48.4, and E0/2, no shut. This should be 47.4. Done. Let's run MPLS LDP router ID to loopback 0, and only on interface E00, which is towards the R3, enable MPLS IP. Come back. Let's run EIGRP. That's a router EIGRP AS100. No auto summary. Network is 4 dot, and network is 192.1.34.0. part of my SP core EIGRP process. That's it. So my SP core is laid up, MPLS is running, and EIGRP is configured inside the core networks. So now if I go to R1 and verify with the ping to R4, that means I should have all the EIGRP routes received. So far we've experienced that earlier as well. So yeah, all the routes are received here. And if I do a ping to 4444 with source of my local loopback, the pings are successful. Let's do a trace to 4444 with source of 1111. The trace is also successful. That means I am reaching to R2 using MPLS path, R3 using MPLS path, R4 is the PHP for, R3 is the PHP for R4 routes, so it's giving the packet as an IPv4 packet without any MPLS labels. Yeah, those things are fine. Absolutely everything is working fine. So now let's go ahead and establish this PE to CU routing between R5 to R1 first of all, right? So R5 is acting as the customer edge router, and R1 is acting as the provider edge router. Okay, so let's go ahead and run the configuration. So first of all, this is a configuration for customer A sites. So I'm doing PE QCE routing for the customer A and customer B. That's the whole idea. First of all, I'll do for customer A sites. Okay, so my first thing first is I will go to R5, which is nothing but R5 is the customer A. This is site 1. Okay, so R5 is customer A site 1, and I would go ahead and configure a couple of loopbacks over here and one physical interface, and then I will run a routing protocol. So let's go ahead and configure the R5, which is the customer edge router. So let me give a host name like that. So host name is R1 provider edge. Okay, do right. R2 should be hostname R2 as a normal provider router. Okay, let's save the config. R3 is also a normal provider router. R4 is your provider edge router. Okay, R5 is your customer edge router. So hostname is R5 CE, and this is for cust A. I can select that, cust A site 1. Okay, that's a good name. This is my R5, which is customer edge router. Is a customer A site 1 router. All right, so save it, and let's go ahead and type the configuration for R5. So it has got a couple of loopbacks. Interface loopback 0, it is 10.1.1.1 and /24. Okay, and it has got interface loopback 1. The IP address would be 10.5.5.5 and /24. It has got a physical link which is E0/0, no shut. The IP address is 192.1.15.5. That's it. You're right. Okay, let's configure R8, which is the customer is site 2. So over here, R8, I say hostname as R8. This is customer A site 2. Okay, it has got 2 loopback, interface loopback 0. This is going to be 10.222 and in /24. Interface loopback 1. This is going to be 10.8.8.8. I just configure the basic IPs first of all. An interface E0/0, no shut. This is going to be 192.1.48.8. There we go. That's it. So save the configs. Yeah. Let's go to R6. R6 should be hostname is R6. This is customer edge. This is for customer B site 1. Oops. Yep. Okay. I've got a couple of loopbacks over here. So interface loopback 0. IP add is 10.111 and /24. Interface loopback 1. This IP address should be 10.666 and /24. And I've got a physical interface which is E00. This is going to be 192.1.16.6. That's all. Save the config. Last but not the least is that router R7. So this is hostname as R7, customer B site 2 as the hostname. I have given this like that CE. Okay. All right. Yep. So now let's go ahead and run that loopbacks. So interface loopback 0. I have got 10.222. Interface loopback 1. This is 10.777. And the physical interface, it's going to be 192.1.47.7. Done. Let's save the config. Okay. So my basic IP configuration of all the customer sites are laid up now. So let's go ahead and run P2C routing. So what I want to do is let me run this protocol of choice called as a RIP between so I want to run this protocol called as RIP, okay, between my R1 to R5, which is provider edge to customer edge of site 1 of customer A. I want to run the protocol as RIP. So PE to CE, PE to CE, or I can say directly, you understand that I'm going to run RIP version 2 over here, okay, as a PE to CE routing protocol. So to do that, let's go ahead and configure for R5 customer A site 1. I should say normal stuff, router rep. I should say version 2, enable no auto summary, and I run that for my network, which is for all the 10.series loopback, it being a classful protocol. Yeah. And for my network, which is the link between P to C, that is 192.1.15.0. That's it. So let me go ahead and copy this configuration to R5. So let's go to 5 and paste it. Yep. So my RIP configuration is running over here. Likewise, I should go to R8. Okay, and let's run from R8 to R4 the P to C routing protocol as OSPF. Just give it a sec. Let me refresh this page a bit. Okay, so if I just do a duplicate to this, and this P to C routing protocol, what I want to run is going to be in OSPF in area 0 as my preferred P to C routing protocol. Okay, so let's go to R8, which is my, so let me just copy this and paste it over here. So this is going to be R8 customer A, but site number 2. So over here, this is going to be router OSPF1. I should say router ID, say 0008. And I want to run OSPF for my network, which is for all the loopback. And advertise this as /8 in area 0. And network, which is the link between 4 to 8, which is 192.1.48.0. And this is also in area 0. Okay, I copy this and now I go ahead and paste it to R8. So over to R8 in the global config mode. Oops, I missed that wildcard mask, I believe. Here we go. I missed that wildcard mask, which is 0.0.0.255. Let me just recopy it again. Done. So my OSPF is enabled on R8. Let's choose another P to C routing for this R1 provider H2 customer B site 1, and let's choose, let us say, EIGRP as the preferred routing protocol over here. So I'm going to choose EIGRP, say AS111 as the preferred protocol over here. Okay, so over to R6. So this is going to be for R6, but R6 is my customer B site 1, and over here it would be router EIGRP AS111, no auto summary, make it classless routing, network for all the loopback, and network for 192.1.16.0, the link between P to C. Just copy that and I go to R6, the global config mode, just paste it, EIGRP is enabled here, and let's go with default routing. So this customer is pointing, let us say R7, which is customer B site 2, is pointing a default route towards the provider edge router. Okay, so let's go ahead and duplicate this. Let's say that I'm running with default route via provider edge. Okay, so I'm doing this. I'm running default route via provider edge. So over to R7. That's very simple. So this is going to be for this side 2. This is customer B, which is R7, and I should point a normal default route, which is 0.0.0.0.0.0.0, and the next hop is going to be 192.1.47.4, which is the next hop of the provider edge router. Copy that, and at R7 I should go ahead and paste it. Global config mode. Done. Let's save the config for R7, R8, R5, and R6. Perfect. So all my configs are done. The P2C different types of routing protocol I have configured, and now let's understand the the overall concept of what will happen if I now deploy this MPLS VPN and do this routing, and how this routing will take place. So how the customer A, right, different sites, how they will actually exchange the routes. Likewise, customer B, different sites, how they will form this MPLS VPN and how they will actually exchange the routes. Right. So let's go ahead and explain this to you, and then we will proceed further. So let's go ahead and talk about. Let's take a new notepad and let's show you some important things over here. So first of all, okay, so I have got something called as the router. So basically your provider edge router, the PE router which you have, it has got a routing table. The routing table can be called as with a different name, right? So sometimes it is called as the routing table, or sometimes it is also called as the global global routing table, right, which contains all the route. And by default, whatever interfaces the router have, E00, E01, E02, E03, whatever interface router have, when you configure any IP address to that interfaces, all those routes get inside the global routing table. Okay, now what you're doing is you have to create VRF, right? So this is the provider edge router. So let's say this to interface is going to this is going to customer A, site 1. This is going to customer A but site 2, right? This is going to different customer. So say this is going to customer B, site 1. This is going to customer B but site 2. That means you should go and create different VRF, right? So let's say you create a VRF called as VRF name as customer A site 1, or customer A VRF, right? This is customer A VRF you created, and all this and what you're doing is you are actually moving that interface. So it is interface number 1, interface number 2. You're moving that interface from the default global routing table to the VRF, right? So make sure that an interface can be either be part of either a global routing table instance, or it can be part of the VRF instance. But a single interface cannot be part of multiple VRF instance. So one interface can be part of only one VRF instance, right? So likewise, you need to create another VRF over here and move these interfaces to that VRF. So say this VRF is customer B VRF. Good. So yeah, this is very simple. So now what happens is you have defined that particular VRFs. Yeah. So likewise, think like this, that you have got in your topology, what you have is you have got this global routing table, right, which is the provider edge router, right? And you have got an interface, say it is E0/1, okay, and this E0/1 is going to customer A, right? And you have got another interface which is say E0/2, and E0/2, this particular interface, say it is going to customer B, right? That means you need to create a VRF for customer A and a VRF for customer B, right? So now this provider edge router, over a path, you might have other routers as well, right? Other routers as well, but it goes and talks to another router which is also a provider edge router, okay? And Also, it has got the similar situation over here, right? It has got some interface. Just as an example, I'm taking E0/1. It is going to customer A, different site, and we have got another interface over here, which is say E0/2, and it is going to customer B, different site. So this is say site 1, this is say site 2, right? This is say site 1. Yeah. So now the point is, when those routes of customer A will be, injected, it will appear in the VRF instance. When those customer B routes will be injected, it will appear in that particular VRF instance. Now how do I actually, propagate that route, right? So this particular routes, okay, there is a protocol of choice that has to be, made up for doing the P2P routing. Because that P2C routing, you can choose any IGPs, but to propagate that route from the VRF of customer A to the VRF of customer A between the two provider edge, right, there is a protocol of choice. The protocol is called as BGP protocol. It's a modified version of BGP, right, which we call that as a multi-protocol BGP, multi-protocol BGP. Or we can, simple words, you can say it is called as MPBGP, multi-protocol BGP. So the function of MPBGP is to propagate that particular route from that VRF table to the other provider edge router to that particular VRF table. Now what happens is, when you create that, so there is another table which forms up, this is an MPLS enabled router. So what happens is, to distinguish this particular VRFs. So this is the VRF of customer A, and whatever routes I keep here, that has to be kept unique and separated from this VRF of customer B routes, right? So to distinguish, there is a distinguishing factor, which we call that as a route distinguisher, right? There is an element called as a route distinguisher, or the simple word, we can call that as a RD. Think like this RD as your element to keep those routes separated, right? Keep those VRF routes separated. So the route distinguisher has got something called as the way you represent that, it is like an AS number colon the customer, right? The customer number. So both are like 32-bit values, right? Total, it gives you a 64-bit value. So the route distinguisher, it is used to attach with that particular VRF based routes. So think like for customer A now, how the route will look like. It's suppose it has received that 10.1.1.0/24 route. This provider edge router has received that 10.1.1.0/ route from the customer A site, right? So, and it goes to the VRF over here. For customer A, it will be added, the route distinguisher value will be added. So I will add that, so this is 100 as the AS number, okay? So I give the value as 100:1, and this is your followed by the network, which is 10.1.1.0/24. So this becomes the route which you have received, right? Likewise, this particular route is now called as a 96-bit route. It is called as a 96-bit route because this value of the route distinguisher itself is 64-bit and this is of 32-bit, right? So when you sum it up, it becomes a 96-bit route. It is also called as a VPN v4 route, okay? And likewise, so there is a table which gets created, a separate routing table that gets created. It is also called as a VPN v4 routing table, or it is also called as a MPBGP routing table. So likewise over here, I will have a VPN v4 routing table or we can say that I have this MP BGP routing table on the provider edge router as well. So whenever the VRFs are receiving those particular customer routes, they are tagged with, you know, this particular RD value along with the customer route. Now similarly, you know, you have received this particular customer route, let us say 10.1.1.0 is also received here from customer B to that provided edge of customer B. So how do you distinguish that? You can distinguish that like that. So you can give, you know, the AS number, say it is 100, but this is customer, different customers, so it's 100:2 followed by 10.1.1.0/24. right? So these two routes are separate. So this is for customer A and this is for customer B, specifically customer A site 1 for customer B site 1. So by having this route distinguisher factor, you are actually differentiating these routes from each other and keeping them, you know, isolated and keeping them separated, right? So this is very, very important. So what you do now is every VRF that you see here, you know, will actually go and receive those customer routes. There will be a VPN v4 routing table that will be formulated. It will we will run this MPBGP protocol, and the function of MPBGP protocol is to propagate this route. So I'll have a PE to PE communication. The PE to PE communication and exchange of that routes will happen from that VPN v4 route of one P to another VPN v4 route of another P, right? And the protocol that does this job, it's called as MPBGP. So MPBGP becomes the control plane protocol to exchange the VPN v4 96-bit route from one provider edge to another provider edge. Okay, so I hope this particular part is quite clear to all of you, right? The next important thing is to understand something called as, you know, route target. Okay, so let's take another diagram for that. So what we have leveraged so far is I have got a provider edge router, okay, which has got a global routing table, and we are creating, you know, separate instances of VRF, right? And likewise, what happens is a VPN v4 routing table also gets created, right? So similarly, I'll have, so this is your VPN v4 96-bit routing table, and these are your VRFs, as you know that, right? So likewise, you know, I'll have another provider edge router over here. This will also have separate VRF instances that we want to create. So we'll create those, put the interfaces in the respective VRF. They will talk to the customer and get the routes. That's fine. But what happens is now I will have this VPN v4 routing table that will be created for me, which will have this 96-bit route along with the route distinguisher, right? And now the job is, by using that MPBGP control plane protocol, right, I need to establish this MPBGP neighborship between this two provider edge router and ensure that this 96-bit routes get exchanged using this MPBGP protocol, right? So the whole idea of, you know, a route distinguisher. So the whole idea of a route distinguisher. So every VRF that you see here will have a route distinguisher, right? And this route distinguisher is, the main job is to make the route unique, right, in that MPBGP table, right? Make the route unique in your MPBGP table. That's the major job of the route distinguisher. Now the major point is, you know, so when I propagate this particular, you know, customer A route, so this is my customer A route of site 1, and this is customer A route of site 2, right? Now those customer A route are tagged with, you know, the respective RD value of, say, 100:1, and those things are fine, right? Followed by the routing information, that's fine. Now this is your customer B route of site 1, and it will also hold the customer B route of site 2. Now the job is, those routes are present inside, separately. I should use this color in that particular VPN v4 route, and the distinguishing factor is that RD value, right? Route distinguisher. So I've got a RD value of 100:1 for customer A, and RD value is 100:2 for customer B. Likewise, you know that. So these routes are inserted into that particular VPN v4 route. So I have got 100:1 as the RD value for customer A, and 100:2 as the RD value for customer B. Now there is another component, which will be used to propagate that route using MPBGP between the PE to PE, right? We call that as route target. Okay, so this component is called as route target. So let me take another color and write it over here. This is called as route target. Okay, route target is nothing but it's kind of a tag, right? It's kind of a tag that is normally attached with that particular route. Okay, and this is part of your BGP attribute of extended community. So BGP has got multiple attributes, as we all know, and there is an attribute called as extended community attribute. So this route target is part of this BGP extended community attribute. Okay, and it uses the similar format, right? It uses that similar format of that route distinguisher, right? So which is basically like RD. So it's same like RD. So even RT uses the same format, which is the AS number followed by with a colon with the customer number, right? So what we have is we should define something called as the export route target and the import route target. Okay, so whenever you're defining the VRF, make sure that you define the route distinguisher for that particular VRF, and also you should define the route target for the VRF, right? So whatever, so for example, I can define my route target, but I have to define two things over here. One is called as export route target, and I have to define something called as an import route target. Okay, so ensure that whatever routes I'm exporting from customer A site 1, right, that should be exported from that particular VPN v4 route, that should be exported and given to the VPN v4 route of the provider edge, right? So this particular receiver provider edge should understand that, okay, the import route target should match. So whatever export route target I set, make sure that the import route target should match, and accordingly that particular route will be inserted to the right VRF. Okay, so for example, for customer A site 1, my export route target, say it is I'm giving 1:1. Okay, that means over here when I define the route target, okay, my import route target should be 1:1. Okay, and this I'm defining for the customer A, right? Customer A route. Okay, customer A for site 1. This is for defined for customer A for site 2. Yeah. So the whole idea is, my export route target, the tag should be matching with the import route target tag. Likewise, if I export here the customer A route, right? If I export here with a value of 1:2, I'm talking about customer A, okay, not for customer B. This is again customer A route, right, which is same. But I'm exporting those routes, ensure that here I should import it using the same value, which is for again the customer A route, right? So the whole idea is whatever export route target I set, it should match with the import route target on the neighbor side, the neighbor P router, and likewise whatever export route target I set on the neighbor side, it should match with the import route target of mine. Now this is for customer A. Now for customer B, you can have different one, right? So my export route target for customer B. Over here it could be say a 2:1, right? Over here my import route target for customer B should be 2:1, and say my export route target for customer B over here it is say 2:2, and my import route target for customer B routes should be 2:2, right? That is the way by which you can, the VRF v4, I mean the VPN v4 routes will receive it, and they will check the export import labels, then only it will be properly distributed to the respective VRF. But normally what the service provider does is they normally keep the route distinguisher value and the route target value same, okay, just to avoid any sort of confusion, right? So think about this first, let us say PE1 over here, right? PE1. So what PE1 will do is that PE1 has said that okay, my route distinguisher value for customer A, the RD value is 100:1, and my export route target and also the import route target for customer A is also going to be 100:1 because I use the same format. Okay, likewise it will have the same thing over here, for customer A, for this provider H is P number 2 at the same format. So which is for customer A over here, I'll say that my route distinguisher which I have made, it is 100:1, and the export route target over here it is 100:1, the import route target over here it is also 100:1. Okay, now for customer B you can keep separate. For customer B you can say, just to make it simple, right, my route distinguisher it is 100:2, so my export route target is same, my import route target is same, right? Similarly for customer B over here it is for my customer B over here it is the route distinguisher value, it is 100:2, right? And my export and import route target is going to be same. Yeah. So by doing which, what happens is you come out of that particular confusion of setting different numbers for route distinguisher, different values for route targets, and you make your life easy, right? So more into it, when you see that configurations are happening, you'll see that okay, it's very easy to define the route distinguisher and route target following which. So whatever the whole idea is, whatever route target value I set, that should be specifically if I set an export route target of 1, so yours should be import route target of 1 for customer A. So you want that customer A route should go to customer A routes into a specific customer A VRF, right? So it should not go to any other VRF. So customer A route should go to customer A routes itself, isn't it? That's the reason the route targets are used to propagate it in a unique fashion. So the whole idea is to keep that route distinguisher and route target value same, so that the export import it matches and we can export the route properly on the right VRF of the customers. So last thing is when you are defining the VRF, okay, there are certain steps that you take. So when you define the VRF instances, what are the steps you are taking? The first step is you need to create the name of the VRF, and the name of the VRF is always locally significant. Always ensure that the name of the VRF is locally significant, right? So ensure that the VRF name, it can be same, can be different, but it is locally significant. Yeah. Number 2 is the route distinguisher you should set when you are defining the VRF. So say for customer A, I am sending, say the name that I gave over here, that is customer A, and the route distinguisher, say it is I'm giving us 100:1, and this is in the format of AS number : customer number, right? Next step is going to define the route target, and route target can be of two types, either export route target and import route target, right? Export and import route target should define those values. So whatever route target I set for export, that same route target you should have for import. Whatever route target you set for export, the same target I should have for import. Okay, generally you keep it same with the RD, so you omit any sort of confusion. Number 4 is basically you keep the respective interfaces of the router in separate and specific VRF instance. That's important. So make sure that you select the specific interface and you know that which interface will go to which VRF. That's very important. And then you choose what routing protocol you should run, right? The routing protocol that you choose to run, right? Routing protocol that you should run on that particular VRF instance. So these are the important 5 steps you need to take when you are defining the VRF instance on the provider edge router. Okay, so once you have this thing in place, then you are good to go, and go ahead and follow the next topic. So what we'll do is, in the next topic, we would go ahead and talk about the different aspect of it. So one second. Yep, so what we'll do is we'll go in the next topic, we will go and see the configuration of the VRF on the PE router for customer A. Okay, and then we will run the respective protocols as we have discussed, right? So you've seen me doing reversion to OSPF, default routing, EIGRP as the PEC routing protocol on the customer edge routers, and we'll leverage those protocols as the PEC routing protocol on the provider routers. So these videos are coming up soon, and yeah, join with me. I hope it is clear to all of you. Thank you for watching. I'll see you in the next lecture.